Yesterday, we were dealing with equations that involve sine or cosine of 2 theta. Today, you'll notice we're going to be looking at what happens when we have a 1/2 theta instead of a 2 theta. So go ahead and start by writing down this example, think through it, and then we're going to see how to make use of it. Now, you'll notice the last thing you wrote down here is 360 divided by 1/2 is 720. We know to do 360 divided by 1/2 because our notes from yesterday told us that we do 360 divided by the b value, where b is whatever's multiplied by x or theta. Now, if I'm going to do 360 divided by 1/2, 360 divided by 1/2 is the same as multiplying by its reciprocal. That is 360 times 2 over 1, which of course is 360 times 2. So that's why it ends up equaling 720 degrees. Now that we know that, we can take a look and see how this affects the graph for this equation. So I'm now going to graph y equals sine of 1/2 x. This time I'm dealing with sine. X and theta work the exact same way. All right, so 1/2 x means I'm only going to be completing half of my normal cycle. Now normally sine would start in the middle, it would go up, middle, bottom, middle, like that. If I'm going to complete half of that between 0 and 360, that means I'm only going to be completing these parts. Only that much of the graph is actually going to be showing up. And if I'm going to do that, that means instead of putting a point every 90 degrees, I'm going to be going out twice as far for each point I plot. So I'm going to be putting a point every 180 degrees. So let's go ahead and see how that's going to look. First point for sine starts in the middle. Next point, I go to the top. Now, the top, though, is over at 180 instead because it's twice as wide. It's being stretched out. And then if I go out another 180 degrees, I get to 360 where I'm back to middle. So this is what our graph of y equals sine of 1/2 x would look like, at least between 0 and 360. Yesterday we saw how we could tweak our scale to show one full cycle. I also want to show you what that might look like for this graph. So here we have the graph where we can go ahead and label our scale how we want. Remember, I was putting a point every 180 degrees. That's because I need to get out to 720 by the end of this. And if I take that 720 and divide it up into 4 pieces, each one is going up by 180 degrees. So then this is what my scale would look like if I'm going to try to show one full cycle. Now, knowing that, and that I'm putting a point every 180 degrees, I can go ahead and start plotting sine like I normally would. Sine starts in the middle, and then goes to the top, middle, bottom, and then middle. And so this is what our graph would look like if we adjusted our scale a little bit to make one full cycle actually fit on there properly. The last one we're going to be doing today is this graph. So we're now going to start taking a look and seeing what happens when we have a bunch of stuff going on in it. So we got y equals 2 times sine of 1/2 x minus 1. And again, a little side note, if I had written theta here, that would also be perfectly fine, and it would all work exactly the same way. All right, first thing I want to do is identify my midline and my amplitude. So midline, remember that's whatever this number is at the end that's been added or subtracted, and the amplitude is whatever the number is that's multiplied out front. So I start by drawing in my midline at -1, and then I'm going up 2 and down 2 from there. Now, I need to start graphing my sine. Sine's going to start in the middle, and nothing's changed that. And then my next point is going to be at the top, but it's not going to be over here at 90. The 1/2, remember, changes that. The 1/2 actually makes it twice as wide, somewhat counterintuitive, but the 1/2 makes it twice as wide here. So my next point goes at 180 degrees, and then my next point after that would go at 360. So then this is what our graph would look like, at least between 0 and 360. Notice we're only seeing half of one cycle. Remember, that's what that number that's multiplied by x or theta means. It means this is how much of a cycle we can actually see when we go between 0 and 360.